Hello, fellow chemists. In this video, we're going to take a look at ionic bonding. This is labeled as an intermediate level video because it assumes you have a basic understanding of bonding. If you need a review of that topic, I'll put a link in the upper right-hand corner. So let's talk specifically about ionic bonds. As mentioned before, ionic bonds are when one atom loses one or more electrons and then another atom gains one or more electrons. And by doing so, both of those atoms then become ions which have charges, which then attracts those two ions to each other, thus forming the ionic bond. So let's take a look at a few examples of this. If we have a sodium metal, or sodium atom here, which is a metal, and then a chlorine atom, which is a non-metal. Remember, it is a metal and a non-metal that forms ionic bonds because they have large differences in electronegativities. And the reason why they have large differences in electronegativities is because the nonmetals, in this case chlorine, almost has its valence shell or its octet filled. It has 2, 4, 6, 7 electrons in its valence shell, so it has a very high electronegativity, a very high desire to capture one more electron, whereas sodium, which is a metal, has only 1 electron in its valence shell, so it has a very low electronegativity. So chlorine is going to pull the electron from sodium over into its valence shell. When this happens, this outer shell for sodium ceases to be its valence shell. It loses that shell altogether. And then its next shell, the next inner shell, becomes its valence shell, which is then filled, which is kind of a sneaky way for sodium to fill its valence shell. By losing that 1 electron, its next shell is filled. And then by gaining 1 electron, chlorine will fill its octet or fill its valence shell as well. So let's see what happens when this occurs. Sodium loses its outer shell, and the electron then, and I'll draw the electron in red here to show that it came from sodium, goes into chlorine. Sodium now has a new valence shell which is filled. And sodium now also has a charge. It lost an electron, so it has a +1 charge. And since chlorine gained an electron, it has a -1 charge. The electron arrangement for sodium was originally 2, 8, 1, but it lost that outer electron, so its new arrangement is 2, 8, thus showing its outermost energy level is filled. Sodium is now also an ion, meaning it has a charge. And metals that become ions have positive charges, and they are called cations. So sodium is not only just called an ion, but it is now called a cation because it has a positive charge. Chlorine has gained an electron, so its electron arrangement changes to 2, 8, 8, and this shows that chlorine has also filled its octet. Chlorine is now also an ion because it now has a charge, but it is called an anion because it has a negative charge. So nonmetals like chlorine, when they become ions, are negative ions, and they have negative charges, therefore they're called an anion. And metals like sodium, when they become ions, they have a positive charge, and they are then called cations. And you can see how the electron arrangement causes their octets to be filled. What these two ions would then do is they would be attracted to each other because of the opposite charges. And you would have an NaCl molecule. And again, a molecule is when you have 2 or more atoms that are bonded together. So let's take a look at another example of 2 atoms on the periodic table, a metal and a nonmetal, that will undergo an ionic bond. So now we'll take a look at, say, lithium and fluorine. So lithium, which is element number 3, has 3 protons and 3 electrons, and fluorine, which is element number 9, has 9 protons and 9 electrons. So lithium will have 2 shells. We'll draw that out there. And fluorine will also have 2 shells. Lithium will have 3 protons in its nucleus. Fluorine will have 9 protons in its nucleus. This is our lithium, and this is our fluorine. Both have 2 electrons in their inner shell, their first shell. Lithium has 1 electron in its second shell, that's its valence shell. And fluorine has 7 electrons in its second shell, which is its valence shell. This is the valence shell for lithium. This is the valence shell for fluorine. Again, because of where lithium is on the periodic table and that it's a metal, it's going to have a very low electronegativity. Fluorine's going to have a very high electronegativity because it's all the way over on the right-hand side of the periodic table. It's going to be much easier for lithium to lose 1 electron than to gain 7. So it's going to lose its electron to fluorine. Lithium's original electron arrangement was 2, 1, and fluorine's original electron arrangement was 2, 7. Once this electron gets pulled over to the fluorine, the outer shell of lithium is gone. It now has a new valence shell here, and it's filled. It has 2 electrons in it. And once lithium's electron goes over to fluorine, fluorine's outermost shell is filled as well. The new electron arrangement for the lithium ion is just 2. And lithium is now an ion because it has a charge. And since it has a negative or a positive charge because it gained 1 electron, this is called a cation. The fluorine now has 1 more electron than proton, so it has a -1 charge. Its electron arrangement is now 2, 8. It is an ion, and it is an anion because it has a negative charge. The lithium and the fluorine will then be attracted to each other, so they will form a bond, an ionic bond, and they are then called a lithium fluoride molecule because there are 2 or more atoms bonded together. All right, so that's a couple examples of atoms undergoing ionic bonding. That's it for this lesson. I hope you learned something, and I'll see you in the next video.